Welcome to our video learning about box plots, also known as box and whisker plots. Today, our learning objective is going to be to determine the 5-number summary of data, creating a box and whisker plot, and also interpreting a box and whisker plot. Box plots are created using a 5-number summary. The minimum is the lowest number of the data. The maximum is the highest number of the data, and they are the minimum and the maximum of our graph. Now, the median is half of our data, so we find the middle number, but always remember, order them from least to greatest first. So then it's the middle number. If we have an odd set of data, the middle number is your median. If we have an even set of data, then the middle number is the average of the two. So you would take this plus this, find that total, and divide by 2. So the median then would be right here. Now, since the median is half of the data, that means everything from the median to the max is 50%, and everything from the minimum to the median is 50% of the data. The first quartile is found using this first half of data, and it's finding the median of that first half. So we find the median, the middle number of the first half of the data, and remember, if it's a tie, I would take the average of the two middle numbers. So if this is the median of this first half, then this is 25% of your data, and this is 25% of the data. All right, the third quartile range is here, and that would be the median of this second half of the data. So it's the middle number again, only this time with the second half of your data. So if this is the middle number out of a total there, that would be a quarter of your data, and that also would be 25% of your data. So all of this is 100%. The median is 50. Quartiles split it into fourths. We are going to create a box and whisker plot of this data. And first, we're going to determine the 5-number summary of the heights of 12 players on a soccer team. Before we begin, we need to order our data from least to greatest. Now that our data is listed from least to greatest, we can find the medians. And before I begin, our heights are in inches. I forgot to mention that. All right, I always start with my minimum, so 58, and my maximum, so 72 inches and 58 inches. All right, now to find the median, the middle number. So I'm going to cross them off. And it becomes a tie between 65 and 66. So I'm going to find the average of them. 65 plus 66, all divided by 2 is 65.5. And that makes sense because that's our middle number here. Now, if we have a ton of data, I like to count them up. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. And 12 divided by 2 would give us the middle number, which is 6. Well, that means I have 6 data points on the left and 6 data points on the right. So I needed to find my 6th number. 1, 2, 3, 4, 5, 6. There we go. 1, 2, 3, 4, 5, 6. So I could have found the median that way as well. All right, now that we have our median, let's find our first quartile, which is taking the first half of our data, which is 58 to 65 here. Now you could cross off again and find that middle number, or you can take 6 divided by 2, which is 3. Since we got a nice number, that means it's 3 from the left and 3 from the right. So once again, I have a tie in between 62 and 63. So 62 plus 63 divided by 2 is really 62.5, which makes sense that that's the middle number in between there. The third quartile, I better be doing the same kind of thing as that first quartile. I've got 6 data points to the right, so I can do 6 divided by 2, which is 3. 1, 2, 3 from the left, 1, 2, 3 from the right. I've got a tie, so I'm going to do the average. 67 plus 68 divided by 2 is 67.5. Let's finish this example by drawing the box plot. All right, so I know my minimum is 58 and my maximum is 72. So I'm going to draw just a little line graph here, and I'm going to say this is 50, 60, 70, and 80. I'm just drawing a sketch. So my first example here, my minimum is 58, so that's about here. I'm going to put a point. Our maximum is 72, so that's about here. I'm going to put a point. Now, my median is 65.5. Well, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from 60 to 70. So 65.5 would be right about here. And then the first quartile is 62.5, so that's right about here. And 67.5 would be right about here. All right, so this box part, that's the interquartile range. This is our median. This is our quartile 1. This is our quartile 3, and we can draw our whiskers. What that means is 25% of the heights is between the minimum and quartile 1. 25% of the heights were between quartile 1 and the median. 25 from the median to quartile 3, and 25% of the data is from the quartile 3 to the maximum. And remember also, I could say 75% of the data is quartile 1 to the maximum. Or I could say this is 50% of the data, because that's 25 plus 25. We can look at this in lots of different ways. Now we're going to take a stem and leaf plot that represents the grades of students in algebra, and we're going to create a box plot by first finding the 5-number summary of the data. I first like to total up how much data I have, and if you count it up, you do have 29 total data points or total scores. And the key says 7/3 is 73, so that means like 6/4 would be a 64. I can identify my minimum right away, and be careful that you don't use this 55. From the bottom here, we're going to go left to right, so 50 is our minimum. And the maximum is 99, not 92. It's a very common mistake. So on top, we need to make sure we go right to left. So our maximum is 99. I can begin our sketch by looking at a range from 50 to 99, which is 49. But I'm starting at 50, and I'm going to go in increments of 10. So 70, 80, 90, 100. And our minimum is 50, and our maximum is 99, so really close to that 100. Now let's find our median. The nice thing is stem and leaf plots are listed from least to greatest, and I could write it all out, and I could take the lowest, the highest, the lowest, the highest, and find the middle number, which does get confusing, and we might not pick the right one to cross off by going left to right or right to left. See, I lost count a little bit, but more because I was talking. It looks like that 83 is our median, but it is pretty tricky. So there is a nice way of doing this, and it's finding the middle number by taking the number of data points, which is 29, cut it in half to find that middle number. 29 divided by 2 is 14.5. So that means I have 14 pieces of data from the left, the beginning, 14 from the end, and that middle number, that 15th number here, is going to be our median. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 80 is our 15th number here. And at the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15th number. So I earlier had counted the 83. I was talking while I was doing it, but that was a very common mistake. This way, dividing, I can count from the beginning, the end, to really make sure I have my median. Now to find our first quartile, we need to find the median of the first half of the data, which is from here to here, not including the 80, because it's like that line is in the middle. And then our second half of the data is above that 80. Plotting the median here is at 80. So there's our third point of our 5-point summary. All right, now there's 14 before the median, there's 14 after the median. So we pretend like that line's right on that 80. We don't include that in the count. So our first half of the data, we could find the median by crossing off beginning to end, but like earlier, I'm nervous about making a mistake. So I want to take my 14 data points and divide by 2 to find my median, or what number would be the median. So that's 7. So it means the 7th number from the beginning, the 7th number from the end. So let's count it out. 1, 2, 3, 4, 5, 6, 7. So there's our 7th number from the beginning, and 1, 2, 3, 4, 5, 6, 7th number from the end. So really it's 68 plus 69 divided by 2 for our first quartile. And that, of course, would be 68.5 because that's halfway in between those two. Let's graph that. 68.5 is about here. One more part, that third quartile is the median between the median and the maximum. So to find that middle number, there are 14 data points just like before. You can also count them out there. And I like to, once again, divide by 2 and I get 7. So the 7th number from the end, 3, 4, 5, 6, 7, and 7th number from the beginning of that median, 1, 2, 3, 4, 5, 6, 7. So that is 89 plus 92 divided by 2. This one's not quite as easy to see, so maybe you grab your calculator to do that. I get 90.5 for that third quartile range, which is about here. Okay, I'm going to clean this up a little bit, and then we'll talk about the graph. Quartile 1 to quartile 3 is your interquartile range. Half of the data lies in there. The minimum to quartile 1 and quartile 3 to the maximum also includes 50%. So this is 25% of our data. This is 25%. This one's 25%, and so is this one. If I interpret this box and whisker plot, I know that from here to here is 25% of our algebra student scores. So that's pretty cool because they're scoring from 90.5 to 100 there. From our median to our maximum is 50% of the algebra students, and they're scoring for an 80% and above to 99%. So that's cool information. I know that 3/4 of my students, 75% of them, are scoring from 68.5 to that 99%. And 25% of the algebra students are not passing at 50% to that 68. This is very helpful data. The only thing is, I know that 25% of my students are failing or up to that 68% mark, and I only know how many are failing and how many are actually passing by looking at our stem and leaf plot, or if there's another table of values. In this case, about half of them are failing and half of them are passing. I hope this information is helpful for you as you do your homework and encounter more box and leaf plots in your future.